Lesson 9.6 is analyzing first derivative algebraically. So without graphing it, they want us to find the intervals on which this function is increasing. So I want you to think about what the derivative is. The derivative is a slope. So when the slope is positive, so if our f prime of x is positive or greater than 0, that means it's going to be increasing on those intervals. If our slope is negative, that means the original function would have been decreasing. And so what I want to do is find the critical points. Find critical points. And those critical points or values are where, remember, it has a horizontal tangent line or undefined tangent line. Those are going to tell you important information. It kind of separates this function in intervals. So I'm going to first take the derivative. 3 times 8/3, the 3's would cancel, that'd be 8x squared plus 14x minus 30. I'm going to find the critical points by setting the slope equal to 0 and then factoring this. So I can divide everything by 2. That'd be x squared, 4x squared, sorry, plus 7x minus 15. This is a slide and divide factor problem, so I'm going to have to take the 4 times negative 15 is negative 60. Factor that. One's going to be a positive, one's going to be a negative. Not 6 and 10. 15 and 4. Not 2 and 30. What am I missing? 5 and 12. 5 and 12. 5 and 12. Okay, so this would be 12 minus 5. There we go. Okay, and then go back and divide by 4. That would be x plus 3, and that would be 4x minus 5. But that's just factoring to be able to solve each of these as a linear piece. So then this would be x equals negative 2, and this would be x equals 5/4. Now this is a polynomial. Polynomials don't have any asymptotes. They go on forever. So I'm going to make a number line here with my critical values. I'm not going to have any endpoints here, like where it says it's on an interval. It's just going to go forever. So let's do negative 2 and 5/4, which is really 1 1/4. We want to think, what is it doing in each of these intervals? So what I'd like to do is pick a point that's going to be here. So let's say negative 3. If I were to plug in negative 3 here, all we care about is the signs. Negative 3 plus 2 times 4 times negative 3 minus 5. Negative 3 plus 2, that's a negative 1, so I'll just say it's negative. 4 times negative 3 is negative 12, minus 5 would be negative 17, that's a negative. And a negative times a negative would make this actually be positive. So that tells me that this is increasing right here. Does that make sense? And then now we want to pick a number in here. The easiest thing to do would be x is 0. So if I had 0 plus 2, I care about the sign, that would be a positive 2. And 4 times 0 minus 5, that would be 0 minus 5, that would be a negative. And positive times a negative would result in a negative. So now I'm going to be decreasing. 5/4 is 1 1/4, let's pick 2. 2 plus 2 is 4, that's positive. And 4 times 2 is 8 minus 5, that's positive. And a positive times a positive is positive. So then we're increasing again. So that's somewhat what our function would do. So then it says find all intervals on where it's increasing. That would be positives. So that would be here to here and here to here. So we're going to say from negative infinity, and you never, sorry, I did my 8. Negative infinity, you always want to use a parentheses there, to negative 2, and then 5/4 to positive infinity. Always use a parentheses around infinities. All right, number 2. Find the x-coordinates of all relative or maxima of f of x. So again, we're thinking of derivative. Relative maxima are going to be, first of all, where the derivative or slope is 0. So that's like finding those critical points. And then we want sign changes. We want a sign change. So think about a maximum here. We want positive slopes to negative slopes. Okay, positive to negative. So let's take the derivative of this. That'd be 15x squared plus 50x. Set the slope equal to 0. I'm going to factor out, let's see, 5x. That would be 3x plus 10. Set those equal to 0, so that's just going to be 0, and then that's going to be negative 10 thirds. Let's make sign chart here. So again, a polynomial has no start or ending. We've got negative 10 thirds is going to be the smaller number, and 0. All right, negative 10 thirds. If that was negative 9 thirds, that'd be negative 3. This is really negative 3 and a third. So let's say we pick negative 4. Let's plug it in here. 5 times negative 4 is negative 20, so it gets a negative. And then negative 4 times 3 is negative 12, plus 10 would be a negative 2. Negative times negative would mean this is a positive. So we're increasing. That's a good sign. Maybe that's going to work. And then let's pick like negative 1. 5 times negative 1 is negative 5, and 3 times negative 1 is negative 3 plus 10 is 7, which is positive, and that multiplies to make a negative. And then let's pick 1. Positive and positive would be positive. So yeah, we're increasing, decreasing, increasing. So our relative maximum would be right here. So that'd be an x equals negative 10 thirds. And number 3, find the x-coordinates of all relative minima. So same thing where we want to figure out where is the derivative 0, where is the slope 0, but a minimum, we want to be decreasing slope and then change to increasing slope. Okay, find the derivative. That would be 2x to the 4th minus 32 x cubed plus 120 x squared. I can take out a 2x squared, so that would leave me with x squared minus 16x plus 60. Okay. Factor this, just a regular basic trinomial. That'd be a negative 10 and a negative 6. No slide and divide. We're going to get 3 different critical points here. This always gets a 0. This would be 10 and 6. Okay, so I make my sign chart. Smallest number would be 0, then 6, then 10. So let's say I pick a negative number, like negative 1, and I plug it in. Negative 1 squared would be positive, times 2 is positive. Negative 1 minus 10 would be a negative, and negative 1 minus 6 is a negative. So a negative times a positive is positive. Pick like 1. That'd be positive. 1 minus 10 would be a negative. 1 minus 6 would be a negative. So again, that's going to get a positive. And then pick 7. 7 squared times 2, that's going to be positive. 7 minus 10 is negative, and 7 minus 6 is positive. So that multiplies to get a negative. So we're increasing, kind of a plateau here, increase some more, and then we decrease. And so this would not count. This is just a critical point because the slope became 0, but it's not a relative max we want right here. So that would be x equals 6. Oh, I forgot minimum. Sorry. Oop. Back up, back up, back up, back up. Sorry. We want negative to positive, and we don't have that. So this doesn't even exist. You would just say, leave it empty, or just, we'll say for this, there aren't any.